Good afternoon, dear students. Once again, let me finish this ammonia in P black elements. So today, here go for that physical properties of ammonia. First is the nature. How the nature of the ammonia is there. The physical properties of ammonia. So first go for nature. It is a colorless gas, strong pungent smell, as I already told you, slightly bitter taste like soap. Colorless, strong pungent smell, slightly bitter taste like soap. Melting point is and boiling point is higher than expected on the basis of the molecular mass because of the association of hydrogen bond both solid and liquid state. So this is very important. There will be a one reason question is there. What is the reason question is there? Ammonia shows higher melting point and boiling point than the expected on the basis of the molecular mass. Why? Because in the molecular structure, association with hydrogen bonding and solid and liquid state, both that states it happens. So that's a higher melting point and boiling point. Come to the second one, shape and structure of ammonia. So here you have the shape is there. Nitrogen is one atom and the three hydrogen atoms with the different chain. Here is one lone pair of electrons are there. Here is then the bond length is how that one 101.7 picometer, and is in the angle between the hydrogen and hydrogen between that nitrogen is in 107.8 degree. So come to this one, the pyramid, the shape is there, no? Trigonal pyramidal structure, three bond pairs and one lone pair, three bond pairs and one lone pair of electrons, bond pair electrons and lone pair electrons are there. Just to remember, very easy. Shape and structure, just to write the structure first, N and H3 with a different one, 107 and 101.7, and trigonal pyramidal with the three bond pairs and one lone pair. This is about the structure. What about the physiology? How it is that? It is a non-poisonous. If you take that one, the taste of that one, it is non-poisonous, affects the tear glands and affects the tear glands. If the ammonia is opened, the tear as usually comes down. That affects on the tear glands and brings tears to the eyes, affects respiratory tracts or respiratory muscles and causes choking effect, fatal in large amount of doses. If you inhale that large amount of that ammonia, it may be a fatal also. It's very clear. Don't go for that negative things. Then density. What about density? Density, the vapor density is 8.5, whereas that of air is 14.4. Observe that one, 8.5 and 14.4, lighter than air. Air has more density than ammonia, so that's a lighter density. Then liquefaction. What is the liquefaction factor here? When cooled under pressure, ammonia condenses to a colorless liquid, boils at 33.4 degrees centigrade, further cooled become white crystalline snow-like solid, melts at 77.7 degrees Celsius. So this is very clear here. What happens here in the liquefaction? When cooled under pressure, ammonia condenses to form a colorless liquid, boils at 33.4 degrees Celsius, but further cooled become white crystalline snow-like solid metals at 77.7 degree. Then we come to that boiling point. Boiling point is 33.5 degrees centigrade. The melting point is 77.4 degrees centigrade. Solubility, higher solubility, that's soluble in water. Then here's observe that one, the water and ammonia, it forms an ammonium ions. There's an ammonium ions and the hydroxyl ion. This is the solubility is more. one volume of water dissolves. See, observe that one volume of water dissolves 120 volumes of ammonia at standard temperature and pressure. So this is about the properties of that, the physical properties of ammonia. Just go through the clear. Yes, it's going to be clear. Yes, I think you got. Make the clear notes. We are going each and every corner of the lesson, so it's very beautiful points are there. Then I come to that next one, chemical properties of ammonia. How that the ammonian chemical properties are there. Just observe that the chemical properties of ammonia. The basic nature. The first we go for ammonia. The basic nature of ammonia. Ammonia acts as a Lewis base due to availability of lone pair of electrons in nitrogen. It accepts the proton and forms ammonia. Acceptor of proton, Lewis base. Donor of protons, Lewis acid. Here's an acceptor of proton and forms an ammonium ion, NH4 ions. So this is about the base. It acts as a base. Here we have ammonia with H plus, it forms ammonium radical here. So then it forms salts with acids. Again, ammonia plus water gives rise to ammonium, then aqueous ammonium radical, and then hydroxide ions. Again, with ammonia with sulfuric acid, it forms ammonium sulfate. It forms a different compounds. Reacts with the zinc sulfate. Again, it forms sulfate. No, here is also sulfate. Here is a sulfate, but here is an ammonium hydroxide. So ammonium sulfate plus zinc sulfate plus ammonium hydroxide, it forms zinc hydroxide and ammonium sulfate. Zinc will be the white precipitate. With copper ions, Cu2 plus ions, it donates its lone pair of electrons. It donates its lone pair of electrons and to metal atoms or ions, and it forms a coordinate covalent bond. So please go through this one. It forms with copper, it donates the lone pair of electrons and form coordinate covalent bond. What bond is to be formed when ammonia is going to treat it with copper? That's a covalent coordinate bond. One more questions to be expected. Form a complex compounds, helps to detect the test for ions. Detecting of ions, it also comes here with copper. Here is a copper 2 plus aqueous and ammonia, it forms cuprous nitrate, cuprous ammonium complex, is aqueous. And uses, we come to the last, uses, very important. In refrigeration, in the qualitative and quantitative analysis, both in refrigeration we use ammonia, and in the analysis of salts, both the qualitative analysis and quantitative analysis we use ammonia. And in the manufacture of ammonia by nitric acid by Ostwald process, manufacture of nitric acid by Ostwald process, sodium carbonate by Salvage process. Two processes are there, nitric acid by Ostwald process, sodium carbonate by Salvage process. And it is very important in that ammonium phosphates, sulfates, nitrates in the fertilizer. It's a main use as a fertilizer. Ammonium nitrate, explosive, it is an explosive. It is also used as an explosive compound. And cleaning agent is used as a cleaning agent to remove the grease and the dirt. The manufacture of urea, this is also again that fertilizer only. It's the most common usable the fertilizer is urea. Ammonia, this is about that the compound structure of urea. It's then excellent fertilizer of nitrogen. So ammonia is used as an excellent fertilizer for nitrogen. In order to provide nitrogen, we use ammonia. We use ammonium fertilizers, especially urea. So this is about the one of the thing of the chemical and the physical properties of the ammonia. I think you are clear. So this I think we took 10 minutes. So once again go through, comes along with the ammonia by Haber's process and this one. Yes, thank you.